Hi guys, this is the second half of your cramming for air review. After teaching all day with that mask on, I just could not do that 2 days in a row. That is really hard to do. I know you guys probably understand because you don't like keeping your mask on all day either, but it's really hard to teach with it on. So we're going to continue this this way. Now, there will be a double point secret word assignment at the end, so I'll make this worth your time. Alrighty, some of you have already done this problem. If you have, feel free to fast forward to the ones we didn't get to. Some of the classes did not get to this problem. All right, we have tank P and tank Q. Okay, tank P begins with 65 gallons of water and empties at a rate of 6.5 gallons per minute. So the equation representing tank P would be similar to tank Q here, except for our starting point is 65 gallons and it's emptying at a rate of 6.5 gallons per minute. So this is the rate it's emptying. Notice it's minus because it's getting less. All right, tank Q, for comparison purposes, is Y equals, it started at 63.5 and it's losing water at 5.25 gallons per minute. And X is the number of minutes. Which statement is true? Tank P empties at a faster rate than tank Q. Well, tank P is emptying at a faster rate than tank Q. That's correct because tank P is emptying at 6.5 gallons per minute. So that part is true. But this one says, and had a lesser starting amount than tank Q. Well, actually, tank P had a greater starting amount. It had 65, and tank Q had 63.5. So A is not correct. B says tank P empties at a faster rate than tank Q, just like the first one. That's true. Tank P is emptying at a faster rate. But this one says, and had a greater starting amount than tank Q. P did have a greater starting amount. So I'm liking B for this one because both of those statements are true. When I look at the last two, I see they both say tank P empties at a slower rate. No, it's not emptying at a slower rate. It's emptying at a higher rate. So clearly the only correct answer to this one is B. Okay. For this one, this is a cylindrical container, and we've already met the volume of a cylinder formula. The volume of a cylinder is pi times the radius squared times the height. Well, they didn't give us a drawing, but they've told us the dimensions, okay? So we're looking for the volume, and we know pi, and it says the radius of the container's base is 5. So we're going to have 5 squared, and the height is 18, so times the height. And this is times 2. So we'll have this, and we'll come over here on our little calculator, and it's already cleared out. Pi, we're going to go with 3.14 times 5 squared, I happen to know, is 25, times the height, which is 18, equals, all right, and so we know, and it says round to the nearest cubic centimeter. So even if we had used a pi button and had a decimal value, this one would be rounded to the nearest whole number, so 1413. Okay. All right. Now, no one has gotten to this one. This is new for all the students. Point M is located at 1010, and point N is located at 1525. All right, you will be given grid paper for the air test, but it will not be numbered. What am I looking for? There we go. It's under edit. I always think it would be under view, but it's not. So you will have grid paper, like, for example, this grid paper here. And they want to know, if you graph those 2 points, which one of these would be on that same line, okay? Well, let's see. Graphing these points, I'm going to need to, I can't do that. All right, so I'm going to move you over here, and we're going to move you over here, because what I need to do is I'm going to just have this be my grid here. And you could do this on grid paper. Now, I think my first instinct on this problem would be to, oh, that's ugly. My first instinct would be to see if I could obviously eliminate any of these. All right. Just by kind of guesstimating. We have a point at 1010 and a point at 1525. You want to do these by fives? That would help, huh? We could do this by fives instead. What a great idea. Let's do that. Then we can just use a more regular XY grid if we do it by fives. Each box is worth 5 is what I'm saying. Okay, so point 1010 would be 10, 10. This would be point 1010. And then point 1525 would be 5, 10, 15, 5, 10, 15, 20, 25. All right. So this line would be like here. Okay, and it's not the greatest line, so we're going to have to understand that it could be off a little bit. So which one of these would lie on it? Well, clearly 0, 0 is not going to be on there, so that one's out. 11, 13 would be like just past here, and it would go up to here. Ooh, 11, 13 might actually be on there, okay? That looks very, very close. So we're going to put a little star next to that one because that might be right. 13, 13 would be 5, 10, 13, 5, 10, 13. I'm thinking no on that one. And 20, 20 would be 5, 10, 15, 20, 5, 10, 15, 20. This is definitely a no. So I'm going to go with B. All right. You probably would have drawn a better graph. Mine not so much. But that's the only way I can think of to do that one. Okay. Next, which graph represents a linear function? Okay, well, first of all, a linear function, remember functions, you have to pass the vertical line test. So like this passes the vertical line test because it only has one point at any given point, but it's not linear, it's not straight, it's got that curvature to it. So that eliminates that guy. This one fails because it's not a function. It's got an infinite number of points all in one spot. That's not a function. This one is also not linear, although it is a function. It's not a linear function because it's curved. The only correct answer is D, because not only is it a function, it passes the vertical line test, but it's also straight, which means linear. Okay. Quadrilateral ABCD is shown. ABCD is translated to create quadrilateral EFGH. What is the length in units of side EH? Well, and I told some of you this yesterday. When you name your figures, the letters have to line up. So ABCD lines up perfectly with EFGH. Okay? So E is the new A, F is the new B, and G is the new C, and H is the new D. So if they want to know the length of EH, what they're really asking you for is the length of AD. So the length of AD is 8. And that's how you do it. Just make sure you line them up. They have to put them in the exact same order. And so that's how you can figure out what side this is that you're looking for on that one. Okay, a statement is shown. The square root of x is a number that is non-terminating and non-repeating. Select all the values of x that make the statement true. All right, it is the square root of x is a number that is non-terminating and non-repeating, which means it has to be a perfect square. Okay. Let me say this better. This is the tricky part. The wording on this is everything. It says the square root of x is a number that is not terminating and not repeating. Okay. If it were a perfect square, wouldn't it terminate? Okay, and it wouldn't repeat, it would just terminate. So what we're looking for is numbers that are not perfect squares, okay? So for example, 1 is not one we're going to pick because the square root of 1 is 1. That terminates, that's all there is. 8 is not a perfect square, so we would pick 8 for one of our solutions. Because if you put the square root of 8 in a calculator, you're going to get a decimal that is not repeating and not terminating. It's just going to keep on going, okay? 25 is a perfect square, so we're not marking 25. The square root of 25 is 5. That terminates. The square root of 81 is 9. It terminates. What about the square root of 125? Oh, that's going to be non-terminating and non-repeating. Okay, so be careful when you're reading these questions. They tend to get kind of wordy and they try to trick you a little bit. Oh, this one. I remember this one. Oh, yes. All right. This one's tricky, and I'm not going to spend a lot of time on it because I don't think we ever talked about negative exponents in this class yet. Or if we did, it's been eons ago. It says two equations are shown where a is greater than 0. What is the value of b? Okay, so whatever number a was, when you squared it, you got this. Okay, so what you have to realize is that a had to have been 1/8 because 1/8 times 1/8 is 1/64, right? Oh. So a has to be 1/64. So if b to the third is equal to 1/64, what's b? Well, what number times itself would give us 64? Okay. Let's think about that. We need the cube root of 64. No, we don't. Because a is 1/8. See how tricky this is? A is just one of these 1/8. So what times what times what equals 1/8? You thinking what I'm thinking? Yep. B is a half. See how convoluted that was? Oh, that was a tricky one. That's why I said we're not going to spend a lot of time on that one because it's weird. Hopefully they don't use anything like that. This one you totally should be able to solve. This is just an equation with variables on both sides. And we did these and did these and did these. All right. We have 6x minus 3 equals 3x plus 12. Our first step when we are solving problems like this is to get all of our variables on one side, and we usually want to get rid of the smaller one. So 3 is smaller than 6, so we'll subtract 3x from both sides. That gives us 3x minus 3 equals 12. Next, we want to get the variable term by itself, so we want to get rid of this minus 3. We can do that by adding 3 to both sides, which gives us 3x equals 15. And then dividing both sides by 3, we get x is 5. Everybody should be able to get that one right. Not so much a little, 1/8 thingy. I get that. That's pretty tricky. Almost had me going there for a minute. But everybody should be able to get problems like this right. Okay, so two triangles, JKL and MNO, are shown. Which transformation can be applied to JKL to create MNO? Okay, first of all, remember what I said. They have to go in order. So J is M, K is N, and L is O. Okay, so L is now over here. K is now here. So let's see, K became N, L became O, and J is M. Okay, so what happened to put this here? Okay, I believe this looks like a rotation. Isn't it a rotation? And so it looks like it was rotated 2 quadrants worth. Okay, so actually this has been rotated 180 degrees this way. So is this clockwise going this way? Yes, it's clockwise, 180 degrees clockwise. A. Pretty fun. Complete the table to create a linear function. Now you would think this would be super easy, but the problem we've got is that they didn't give us like 1, 2, 3. If they'd given us 1, 2, 3, we could have very easily done this. Okay. What you need to do is go ahead and make yourself a rule. All right, and there are a number of correct, there are infinite number of correct answers to this. As long as the rate of change would have stayed the same if all these other missing numbers were in here. Now, if you can't wrap your head around it, let's think of it this way. 0, 1, 2, 3, 4, 5. Okay, so if we want to be increasing at a constant rate, and we start at 0. So let's go, okay, we'll start here with 0 also. And we increase by 1, increase by 1, increase by 1, increase by 1, increase by 1. Okay? Now when you go to fill in this table, you fill in for the 0, you fill in for the 2, and you fill in for the 5. Okay? Maybe you wanted to increase by 2. Maybe you don't want to use that. Let's increase by 2. Increase by 2, increase by 2, increase by 2, increase by 2, increase by 2. Now instead, for 0, you would still have 0, but for 2, you would have 4, and for 5, you would have 10. Okay? It doesn't matter what you increase it by. What matters is that you're consistent and you increase it by the same amount each time. Okay. Now we have a triangle. Isosceles right triangle ABC is shown. In a right triangle DEF, angle D is the right angle. The length of DE is 2 times the length of AB, and the length of DF is 4 times the length of AC. How many times greater is the length of EF than the length of BC? The only way I can figure to do this one is to use the Pythagorean theorem. Oh, hang on a second. Okay, I'm back. I drew the triangle while I was talking to somebody. Anyway, in a right triangle DEF, angle D is the right angle. The length of DE is 2 times the length of AB. So if AB is 3, then this side is 6. Okay? And the length of DF is 4 times the length of AC. So this would be 4 times 3, which would be 12. And they want to know how much bigger is this one than this one. Well, the only way I can see to approach this is to use the Pythagorean theorem twice, okay? In both cases, you're missing the hypotenuse, so that makes it pretty easy. For this guy, we have 3 squared plus 3 squared equals c squared. So this would be 9 plus 9 equals c squared, which would be 18. Okay? Now we need the square root of 18. I'm on it. Oh, let's use this guy. 18 square root. So we have that c for this one is 4.24. I guess that's good enough. What about down here? Okay, well here we're going to have 6 squared plus 12 squared equals c squared. This would be 36 plus 144 equals c squared. And 36 plus 144, not even on. 36 plus 144 is equal to 180 equals c squared. And so if we take the square root of 180, I'll do it over here. 180, square root. We get that c is 13.42. All right. Well, how many times greater is this one than this one? You just do 13.42 divided by that one. So 13.42 divided by 4.24. And we get that it is like 3.16. I'm not sure how they would have wanted you to put the answer in for this. In the old days, in paper and pencil days, you would have probably put 3.165094, but they probably would have you round this to some number nowadays. But that's the only way I can see to actually do that one. About 3 times greater. Okay, so in this one, we have Mario riding his scooter. He rides a scooter to his friend's house. His trip is represented in the graph shown. Which statement describes Mario's ride? Mario first stayed in one place and then rode at a constant rate. Mario first rode at a constant speed and then he stopped for some time. Mario first rode at one constant speed and then at a faster constant speed. Mario first rode at one constant speed and then at a slower constant speed. I think by now we've all figured out this has to be C. Okay, he rode at a constant speed, so this is a straight line because it's increasing at a constant rate. And then he went at a faster constant speed to get this more steeper line. Okay, you should be able to answer that one. Oh, parallels cut by a transversal. We love these. What is the value of x? Well, you know in a system like this, there are only 2 angle measures. There is the acute one and there's the obtuse one. So what is the other measure that we're missing here? All right, well, we know that these two have to add up to 180 degrees. So it's 180 degrees minus 30. That's 150. So all of the obtuse angles in this system are 150s, and all of the acute ones are 30s. And they want the measure of angle x. Well, angle x is an obtuse one, so the measure of angle x is 150. Parallels cut by transversal. Okay, oh, this one. The kids did not like this one. All right. So here we have the value of the square root of k lies between 2.2 and 2.3. Select all possible values of k. Well, the way you really should approach this problem is they're telling you they took a number and the square root is in between this and this. So what you can do is square both of these, and any numbers that are in between those are right. Okay? So you would do 2.2 times 2.2. That is 4.84. And then 2.3 times 2.3, and that's 5.29. And then you just mark all the numbers that are in between those two, okay? No, this is less than 4.84. This one is in between. This one is in between, and this one is more than 5.29, so it was just those two. Now, the other way you could do it is you could go through and you could do the square root of each of these. If you put 1.49 square root, that number is not in between those two. Okay, so you could do it that way also. And along those lines, if we do the square root of 5, the one we answered, the one we picked, what did I do wrong? No, okay, no, I didn't do anything wrong. The square root of 5 is 2.23, which is in between these two. Okay, so you had a choice there. That either way. All right, so here we have some scientific notation. The radius of a fluorine atom is about 5 times 10 to the negative 8 millimeter. The radius of a strontium atom is about 2 times 10 to the negative 7 millimeter. How many times larger is the radius of the strontium atom than the radius of a fluorine atom? All right. Well, here's what you could do. You could go ahead and put these in regular notation. You would do like 5 and your decimals here, and you need to move it 8 places to the left. So it would be 1, 2, 3, 4, 5, 6, 7, 8. Boy, that's getting messy, isn't it? So we'd have 1, 2, 3, 4, 5, 6, 7 zeros. So we'd have point 1, 2, 3, 4, 5, 6, 7. That's the one. And then the other one is 2 times 10 to the negative 7. So we would go 7 places left. 1, 2, 3, 4, 5, 6, 7. So you're going to have 6 zeros. And then a 2. All right. So which number is bigger? Well, this one, even though it seems smaller because it's a 2, because the 2 is closer to the decimal, this is bigger. So you would do 0.0000002 divided by 0.0000005. You could do it that way. Let's see if this little calculator can handle that. I know your TI-30 can do it, but I don't know if this little guy can do it. So we would go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 5. Nope, this one's not going to do it. You're going to have to rely on the TI-30 for this one. Okay, 0.0000005 divided by 0.0000002 equals, and I did them wrong. I was supposed to do the bigger one divided by the smaller one. It's been a long day. That's exactly why I decided to do this video, because today was just atrocious. 1, 2, 3, 4, 5, 6, 7, 5 equals 4 times bigger. Just get 4, just 4. That's how you would do that one. All right. I'm sure the Desmos calculator can handle it. Which point represents the solution to the system of equations? Okay, this line is an equation and this line is an equation. Which point is the solution? It's the point where they cross, okay? The point where they cross is the solution. This is the point that solves both of them. Okay? Easy peasy. A scientist estimates that there are 2.2 times 10 to the 7 walleye in Lake Erie. The total volume of Lake Erie is 4.83 times 10 to the 11th cubic meters. A pool with a volume of 200,000 cubic meters is built to model the lake. How many walleye should be put into the pool to model the conditions in the lake? You know what? I kind of don't want to talk about this one because this one is going to take a while to solve. We haven't really done anything with scientific notation. And Yeah, you don't see this one very often either. I don't want to spend, I figure I've only got 6 minutes left and I don't want to spend it on a problem like this. So let's just skip this one for now. If we have time, we'll come back to it. Okay, two triangles are shown. Let's focus on the ones we have covered. What transformations can be used to show that LMN is similar to PQR? Okay, so what happened here? First of all, there was definitely a dilation that happened. Okay, but let's think about these coordinate points. They told us that LMN is the name of the one and PQR is the name of the other one. So L goes with P. L goes with P. So there was definitely some kind of a rotation too, wasn't there? There had to be a dilation, so we made it smaller and then we rotated it. Let's see, does Q match up with M? Yes, it does. Q and M match up, and R and N. So this one has been rotated just slightly. So we have a dilation and then a rotation, which means C is the correct answer. Rotation, dilation. Okay, here we go. A teacher surveys her students to find out whether they prefer riding a bike or playing soccer. The two-way table shows some of her data. Based on her data, the teacher concludes that if a girl is chosen at random from this sample, there is a 56% probability that she prefers playing soccer. All right, what is the total number of students the teacher surveyed? So we need to fill out this chart, okay? And the only hint they're giving us is that 56% of girls chose soccer, but they didn't give us a number, so we're gonna have to figure out what that number is. First of all, let's see, how many total boys were there? Well, 25 plus 26 gives us 51. So there's 51 boys, okay? We don't know the total number of students. We do know that this amount here is 56% of all the girls, okay? So the amount we don't know, plus, no, I don't want to go that way. Don't want to go that way. Oh, dang it. Hang on a second. Okay, sorry about that. I get more interruptions in the afternoon. Okay, so where was I? All right, we know that there's a 56% probability that a girl prefers playing soccer, but we don't know how many girls prefer soccer. What we do know is how many girls prefer riding a bike. So what percent is left after you subtract this from 100? What percent is this number right here? Okay, well, this number would have to be 44%, right? Because we know that 44 and 56 add up to 100. So if 22%, if 44%, I'm writing it as a decimal, 44% of the total number of kids is equal to 22. Okay, so we have to solve for x here. We can divide both sides by 0.44, and this should give us the total number of girls. Okay, so we would do 22 divided by 0.44 equals 50. So that tells us that there were 50 girls total that were surveyed. You see what I did there? I said this is the total number of girls, and we know that 44% of them was 22, because we know this is 44%. This is 56%. What number goes here? Well, what's 50 minus 22? Because now we know the total number of girls was well, we don't even really need to do this because they're not asking how many girls were playing soccer. They're asking how many kids were surveyed. It's 101. But you could figure it out. Maybe 26. Yep. And so the total number of students surveyed was 101 because you would add those together. All right. A little tricky. If you want it bad enough, you could figure those ones out. What else do we have? Lila and Dwayne each sell tickets at a concert. This is going to be my last problem because I am approaching a half an hour and I didn't want this to go over half an hour. Lila and Dwayne each sell tickets at a concert. They start selling the tickets at the same time. Lila starts with 500 tickets and sells them at an average rate of 5 tickets per minute. The number of tickets Dwayne has left after m minutes is represented in the table shown. Okay, so let's see. At 0 minutes, he had 600 tickets. After 4 minutes, he had 580 tickets. So he sold 20 tickets in 4 minutes. Okay. Which statement is true? Dwayne's average rate of tickets sold per minute is higher than Lila's average rate. Okay, well, Lila is selling at 5 tickets per minute. All right. Dwayne in 4 minutes sold 20. So it looks to me like Dwayne is also selling 5 tickets per minute. Don't you think? Darn right. So this one is not true because their average rate is the same. Lila's average rate of tickets sold per minute is higher than Dwayne's. No. Dwayne begins with more tickets than Lila. That's true. Dwayne started with 600 and Lila started with 500. Okay, so that one is true. And the last one, Lila begins with more tickets than Dwayne. No, that's not true because Dwayne had more than she did. So in this case, C was right. Let me see. What do I have left? And that's it. Oh, okay, so I'm going to need a secret word. Let's see. What would be a good secret word? I was trying to think of something test related, but we don't even use number 2 pencils anymore, so it's like really hard. Okay, how about we just go with tickets. Let's just go with tickets. Yep, we'll use the last problem. That'll be your ticket to 200 points on a practice assignment. All right, you guys have a great rest of your day. Thank you for watching the video, and thank you for trying hard on your air test tomorrow.